Hello, good morning. I am Anil Kumar. I am the participant from rc1300. Today I am creating video on the topic lithography, which is a part of my course that I will be teaching in semester from VLSI technology. So lithography is first we will understand fabrication processes for VLSI devices, which are the different fabrication processes that involves to fabricate a device. First of all, silicon wafer manufacturing. Then after getting the silicon wafer, we go for epitaxial probe, then photolithography. Then after transferring the pattern from the mask, we go to oxidation and etching, metallization, diffusion and packaging. So these are the basically 7-8 fabrication steps that we need to fabricate a simple device. That may be more depending upon the complexity of the device. Lithography is a very key step because it decides the like how your actual device after fabrication would function. And this step will decide in reality how it is going to function. So a light sensitive photoresist is spun onto the wafer, forming a thin layer on the surface. The resist is then selectively exposed by shining light through a mask which contains the pattern information of the particular being fabricated. The resist is then developed which completes the pattern transfer from the mask to the wafer. So basically lithography is a technique to transfer the pattern from the mask to the actual wafer or silicon or any other substrate which you are going to use for your device. So lithography is the most complicated, expensive and critical process of modern IC manufacturing. As I told before, this is the very key step because how fine you design like your mask and how correctly you transfer from the mask to the actual wafer. It is going to decide the whole functionality of your device after actual fabrication. The lithography transforms complex circuits diagram into patterns which are defined on the wafer in a succession of exposure and processing steps. Typically, that is mentioned 8 to 25 lithography steps and several hundred processing steps between exposure are required to fabricate a packed dice. So this is just an example. The number of steps may be actually are more than mentioned here. There may be more for very complex devices based on CMOS IC fabrication. Or as the miniaturization is taking place, the number of lithographic steps usually very high. So actually it will decide the minimum feature size, the minimum line width or line to line separation that can be printed on the surface. That is going to decide your technology node. So the minimum window you can open during lithography is actually your technology. How minimum your device can be actually fabricated. This lithography step that will decide. So these are the basic steps for doing lithography. First of all, surface preparation, clean and dry wafer surface. We take a silicon wafer, we clean, dry, then photoresist apply using the spin coating. We put a thin layer of photoresist over silicon wafer. Then we bake it, soft bake to make it harder. The photoresist is hardened by putting it in an oven for 20 to 30 minutes and depending upon the thickness of your photoresist. Then alignment and exposure on the lithography machine. We use either any like you can say contact printing, proximity printing, or projection printing for transferring the pattern from the mask to the silicon wafer. So then development, the exposed UV exposed photoresist is then developed, then hard bake, then developed inspect. Hard bake is done so that the unexposed photoresist will get harder and it will not etch out. Like if successive you can say fabrication steps, it will be there, it will get stabilized by hard baking after development. Development inspect, that like by the naked eyes, if like you are dealing in MEMS fabrication, then by naked eyes you can see, or you can use the lenses to inspect how fine your transferring pattern. And if you find it incorrect, then you can again repeat the steps. Then etching of the photoresist. The top layer of the wafer is removed through opening the resist layer. Then photoresist, remove the photoresist. Then final inspection. So photoresist is removed by using acetone. So these are the key steps for transferring the pattern from the mask on the desired substrate. These are like process flow for the first of all we fabricate a mask, that is also a step of photolithography. Then there are several steps. Photoresist, this is preparation of the photoresist by spin coating, then transfer the UV to the actual wafer. Then positive and negative photoresist, again depending upon the nature of the exposure, like if it gets soft or it gets harder, it is called positive or negative photoresist. Positive means like it will transfer the, it will actually become soft after UV exposure, it is positive photoresist. And if it becomes harder under the UV exposure, it is called negative photoresist. Photoresist coating, that I have discussed, we put by syringe or any other media, we put the small droplets of the photoresist and we spin it, and how then will be dispersed over all the surface of the silicon wafer. Then coating is done, spin, rinse and dry, and soft bake it. After spin coating, we soft bake it for 20 to 30 minutes at 90 degrees Celsius, depending upon the thickness of your photoresist. Then this is the schematic diagram of the exposure. So this is the schematic diagram of the UV exposure. So there are mirrors like UV. This is the mechanism of the optical mechanism of the UV. Ultimately it will fall upon the mask, and from the opaque area of the mask it will get exposed. And that we have discussed, like UV light will expose to the photoresist, it will become either hardened or soft. Okay, like so this was up to the development will come later to the exposure part. So how this is the basic introduction how photolithography is done in the lab. Okay, thank you. The following